Hi everyone! Today on my bench I have 3 Tektronix probes for repair. Model P6245. Active probes, less than a picofarad capacitance, 1.5 GHz bandwidth. And all 3 have problems. One is not recognized by a scope, another one doesn't show a trace, looks like a loose connection somewhere. And the third one has a problem with this tip cap. It was cracked and glued and now it is loose, falls off. And all 3 have problems with these rubber covers. They feel sticky, looks like the rubber is disintegrating. Strain relief here is completely broken, so is this one. This strain relief is still okay, but there are holes here and it also feels sticky. So let's see what we can do. Let's check. I will start with this one. When plugged in, we should hear relay click and 50 ohm termination should turn on. And that is exactly what happens with this one. And now we can use this probe compensation output, 1 volt peak to peak, 1 kilohertz square wave. And when I touch this pin, we see only spikes where rising and falling edges should be. And that means, I believe, that the probe is working for the most part, but there is a loose connection somewhere, probably right under this cap, and we see capacitive coupling. Now this one, it is not recognized, there is no relay click and no 50 ohm termination, but we see the signal and the amplitude is wrong. We need to fix that. And this one is recognized. Relay clicks and 50 ohm termination is on. And now if I put this pin into the connector and very carefully touch that point on the probe tip, we can see that square wave just fine. Here it is. So let's see how we can fix them. Let's open the one which was not recognized by the scope. I believe we need to pull apart top and bottom covers while pushing on these latches. Let's see if I can manage that. Oh, there you go. That was not very difficult. And now the other side. Almost. Okay, I believe we are in. All right. Oh, and I think I see the problem. Do you see that this flat flex is torn right here? I wonder how did this happen? Someone must have taken this apart and was not very careful. I believe I fixed the problem. Let's put it back together and test. So let's see. Yes, relay clicked. 50 ohm termination is on. And here is the correct amplitude. We have 200 millivolts per division, 5 divisions. So this is 1 volt peak to peak. Perfect. Now let's look at the probe tip and this cap. This is a socket, and all sorts of attachments are readily available, including these so-called solderable tips, but the caps are not available at all. I believe Tektronix treats them as a part of a probe, and only service centers can repair probes for a lot of money, which is beyond economical repair for hobbyists. Now let's look at it this way. This is another socket for grounding attachment, and there we can see active probe electronics on a substrate. Is it ceramic or something else? I'm not entirely sure. And here is this gold-plated pad on the edge, which should be coupled with that gold-plated pad on the back end of the socket. It is also offset from center this way, so I put a mark on this side, and it is recessed, as you can see. So between them there should be a conductive rubber or foam piece. Here it is, a cylindrical piece. So it should provide soft contact between those pads. So perhaps I could just glue this back on, but I see that these cracked caps is a common problem, so it would be nice to come up with some sort of a replacement. Look at this probe. Crack on this side, crack on this side, and a gap here. And this one as well is cracked on both sides. And we also need replacements for these rubber covers with strain relief. Look at this sticky goo. So they are ugly and unusable, and also unobtainable. So let's see what we can do. So I printed this cap. This is PLA. It fits on the probe perfectly, like so. Friction fit. And I arranged a rectangular pocket there. I'm thinking about using this RF gasket. I can cut a small piece of it and put into the pocket. It's going to be a slightly larger piece than the original one, and might have higher parasitic capacitance, or might be a larger antenna or something like that. Not perfect, but this is just a quick prototype using stuff I happen to have right now. And I'm not sure I want to destroy existing caps yet to reuse sockets. So I'm thinking about using this readily available socket. It is almost the size of the original one, but not quite. Unfortunately, it has slightly smaller internal diameter, and Tektronix attachments will not fit, like this tip does not fit in there. But we can use this, again, a readily available thing, like so, and I can sharpen the end if needed. Perhaps later I could find a better socket compatible with Tektronix attachments, but for now, for a quick prototype, this should do. Soldering iron on the lowest setting, 260 degrees. Let's see if it's enough. Yeah, I would think so. And now the small piece of RF gasket should go into that pocket. So here is the result. And let's touch the probe compensation output. Some noise here, of course, because I don't use any grounding attachment here, but it's not the point right now. It works. Now let's look at the third probe, the one which only showed spikes. I believe the problem is here somewhere, so I would like to remove this cap to have a look. But I'm not sure how to do that. Pulling gently didn't do anything. Perhaps it is glued. I'm not sure. And I wonder what these features are for. Oh, look at this. Let's pull this rubber cover off. There you go. Oh, what's that debris inside, I wonder? It doesn't look good, does it? So, I'm not entirely sure how to proceed. Perhaps it would help to warm it up a bit. However, having a working replacement prototype, I am not worried very much to break this cap. I managed to pull this cap off. Let's have a look. Looks like this pocket is offset from that pad, which is different from that cap we have seen before. I'm not sure what's going on. I guess there is no contact here. So let's test this probe with the replacement cap on. Look at this. Perfect. After a few iterations, I came up with this design. I didn't want to worry about cuts here on the strain relief. This thing is going to be printed tail up, and cuts here would introduce overhangs, and I don't want to worry about support right now. If this works, I can revisit it later. Let's rotate this to have a closer look. Printing a small part is surprisingly tricky. Here are my iterations so far, including this first one with rectangular strain relief, and it was too thick, so the part is too stiff. The material here is TPU 95A high flow. So here I switched to round strain relief, but the walls were still too thick, so this is better. I ended up with something like this, with thinner walls, and this is quite flexible. But surface finish is not great. When I printed this calibration cube with no top to measure the walls, this is to check flow rate. 2 lines, 0.4 millimeters each, perfect, 0.8 millimeters wall, no problem. And surface finish here is quite good, but for some reason on this small part imperfections are all over this thing, and I'm not entirely sure why. I experimented with all sorts of parameters like retraction, print speed, temperature, and so on, and nothing seems to help much. Retraction, when I reduced it here, made things worse. Increased retraction here didn't help very much. Looks like only lowering temperature works a bit. So I ended up with 190 or even 185 degrees C. So this is not perfect, but I believe usable. And if you have some ideas how to improve this, please comment below or discuss on the EV blog forum, link in the description. Here is a closer look at these imperfections, or should I call them defects, like this, and this, and this, and this. I'm not sure what's going on here. This is the seam, which is not bad at all. And at the same time, look at this calibration cube. It is perfect. This side has slight deviations from flatness, and the opposite side as well, but no flow problems. And these two sides are perfect. And that was after I saw those problems, and then I went back to experiments with temperature, speed and such. This is 190 and high speed. This is 190 and slow speed. So speed doesn't seem to matter much. But when I increased the temperature, it was horrible. Look at this. So the best result so far was at 185, and I don't think I want to go lower than this. This TPU might not melt very well at lower temperature. So, how do we put a new cover on the probe? We need to desolder the cable, either from the probe head or from the compensation box. I don't really want to mess with this side unless I have to, so let's try desoldering from this side. I think it should be easy to disconnect this BNC connector here. Just pull it out carefully, disconnect here, and then I think I will need to remove this hitch ring just to have a look. It was quite easy to disconnect. I also had to desolder this ground wire. And by the way, let's have a closer look at this part. This chip is EEPROM. It should have probe ID and perhaps some calibration parameters, I'm not entirely sure. This chip is an op-amp. I think I've seen in some documentation that this part is about DC offset. Two trim ports are for zero adjustment and gain adjustment. And there is nothing on this side. Look at this. I just pulled off the strain relief and the cable is crimped here. So it is not super easy. I think it's doable. For example, I could cut the cable off here, enlarge this hole just slightly to pass the cable through, redo the soldering here, perhaps splice these wires to the connector, or just solder directly to the board. But before I go too far, I think I should ask the community first. Perhaps someone did take this apart. Or perhaps it would be easier to attack this side after all. And I also think I should improve my replacement cover before committing to something that would be tricky to replace. So I will publish this as part 1 and I would love to hear your suggestions. I'm going to start a topic on AV blog forum and put the link in the description. Please let me know what you think. Thank you.